Good day, Mr. Agustin. We hope you're doing fine. My name is Ricardo Andres Veliz Salgado from team number 1, and we are going to present to you our PIA of the subject The Science of Motion. We chose as a topic the first of Newton's laws of motion, the law of inertia. In this section of the video, my teammate Paul Raúl Cisneros Guerra and I are going to explain a little bit about the theory of this law. Then our partner Edwin Kuotai will explain our experiment. First off, let's remember the statement made on the law of inertia. An object at rest stays at rest and an object in motion stays in motion, with the same speed in the same direction unless acted upon by an unbalanced force. So, basically it means that objects tend to keep on doing what they're doing until they are interrupted by an unbalanced force. Actually, that's the natural tendency of objects, to resist changes in their state of motion. This tendency to resist changes in their state of motion is described as inertia. The Latin root for inertia is the same root as for inert, which means lacking the ability to move. Inertia isn't an immediately apparent physical property, such as length or volume. It is, however, related to an object's mass. But what's mass? In physics, we talk about mass. We talk about the resistance that a body of matter offers to a change in its speed or position upon the application of a force. Mass is also the quantitative measure of inertia, so we can state that objects with greater mass have more inertia, and it takes more force to change their motion.
There are three types of inertia. Inertia of rest. An object will stay where it is placed and it will stay there until you or something else moves it. For example, those particles stay at rest until you shake a carpet in which they are. Inertia of motion. An object will continue at the same speed until a force acts on it. For example, someone's body going forward when a car stops. Inertia of direction. An object will stay moving in the same direction unless the force acts on it. For example, one's body movement to the side when a car makes a sharp turn. Let's talk about the formula using this law, which is force equals mass times acceleration, which is defined as the rate at which an object changes its velocity. Finally, let's discuss some examples of the law of inertia applied in real-world situations. When seatbelts tighten in a car when it stops quickly. When men in Spain find it more difficult to stop moving because of a lack of gravity acting against them. And when playing football, a player is tackled and his head hits the ground. The impact stops his skull, but his brain continues to move and hit the inside of his skull. His brain is showing inertia.
In this first experiment, we saw that the car was pushed to the wall, and the figurine went out because of the constant velocity of the object, and because the object has stopped but the figurine has the same velocity. For example, in a car accident, the car stopped but the person it still has the constant speed, so it will go forward. So that's why there need to be seatbelt. In the second experiment, we saw that there was the bottle and the base was pulled off. It explains why the friction it would fall because of the object didn't have any force that pushed it, but except the friction that was from the base. So when we moved the base, it immediately went horizontal.